Technical characteristics of the MPU 6050 has an accelerometer, gyroscope, and thermometer. Some applications where it is used are airplanes, drones, robotic projects, boats, inter alia. The features: operating voltage 3.3 volts or 5 volts. If you are going to connect 5 volts, the MPU 6050 regulates it to 3.3 volts with its regulator. Degrees of freedom 6 H's, 3 for the gyroscope and 3 for the accelerometer. Interface E2C into the integrated circuit. Arduino library is L2C DevLib, and the communication with serial data and serial clock. Measurement for gyroscope plus minus 250, 500, 1000, 2000 degrees. Angular rate programmable. Measurement for the accelerometer plus minus 2G, 4G, 6G, HG, and 16G. Measurement of G-force is done by accelerometer. And now the pins is VCC 5 volts, GND ground, serial clock E2C A5, serial data E2C A4, XDA auxiliary data E2C connector to ECs for external sensor, communication, barometers, and accelerometers. XCL auxiliary clock E2C for external sensors, communication, barometer.
In this practice, we will learn how to handle the accelerometer and gyroscope MPU 6050. First, we will calibrate this component, accelerometer and gyroscope MPU 6050. First, we are going to calibrate this component. It is important to add the necessary libraries. If we don't do this, the program will not compile. Well, we start with this first. Int is buffer size 1000, amount of reading used for averaging. Make it higher to get more precision, but the sketch will be slower. In the setup, we initialize the WAR library, which is for the control of the 6050 MPU and for the communication of the Arduino. And the MPU, we need a speed of 115,200. After this, we start an instruction with different structures in the programming for the rest of the offsets. In the void loop, we give the serial monitor command to start reading the sensor with void min sensor, and then we can give the offsets, and then we can read the sensor data in the next program. As we can see, the monitor serial sent us a message. What it says: send any cartridge for start sketch. We put the number 5 and start with the calibration. Okay, with this data collected, we go to the next program to put them in the following spaces. Here we need to put that data, and I will explain this program. Basically, first we declare everything we need for the different angles, for yaw, pitch, and roll, as well as the structure for the MPU control. In the setup, we start the structure for the MPU and the communication and testing of the connections. In the void loop, In the boot loop, we have to wait for correct available data length, should be a very short wait, and then the display initial world frame acceleration, adjusted to remote gravity and rotated based on no retention from questioning. And after compile the program in the monitor serial, we have to send a character, and then the data of the MPU is shown.
Well, here we have the connection of the MPU 6050. The first two pins are connected to the power and the ground. The next two pins that are serial clock and serial data are connected to create the communication between the model and the Arduino, send information and represent on the monitor serial. And the last cable is for the interruption that represents the data interruption that is connected to the digital pin number 2 in the Arduino. We can see that if we move the model in the monitor serial, we can see the new values for the yaw, pitch, and roll. Here we have the movement parameters represented in a graph. The color blue is the yaw. The color red is the roll. And the green is the pitch.
So here we have two servomotors which are in charge of the pitch and roll. And as we can see, there are several type of cables, which are the jumpers, which are going to be the main communication between the Arduino and the servos. As you can see, the orange cable is to the output of the Arduino, the digital outputs of PWM. And then we have the green, which is going to be the power, and black and white, it's going to be the ground. So this is going to work due to the MPU 6550. We connected 5 cables, which are for the communication, the clock, serial data, and stuff like that. The ground is the green one, and the VCC is the yellow one. The last one is the white, which is the interruption one. So in the code, we have 3 libraries, which are the SPI, wire, and Servo. Some of our classmates said what's its function, so I'm going to continue. We define the servos in Servo X and Servo Y, and then we declared the accelerometer variables as double, ACX, and the other letters. So we started. So I'm going to update the program to the Arduino. Just let's wait a little bit. It's not charging. So we can see that the program is updated in this part to the Arduino. Then we are going to show the Arduino and the function. Our 5 voltage supply is this cable, which is going to be connected to the computer, as you can see right over here. So it's going to supply the current by these two cables that are in the program. Then we're going to start moving. This is the roll, which is this one. It has a delay due to the program structuring. Then I'm going to make the pitch. It moves a little bit due to my hand is not like precise at all, so it's going to move. Then if I move these two, it moves like a little bit with a delay of 500 milliseconds. Thank you.